In this video, we're going to look at what happens when we have a factor of expansion or compression in front of our quadratic equation in vertex form. So previously, we've looked at equations that have a p-value and a q-value. Today, we're going to look at functions that have an a-value as well. So the first function we're going to look at is y equals 2x squared. Now, in blue, I'm going to graph our regular function, our y equals x squared. So over 1 up 1, over 2 up 4, over 3 up 9. Same thing in the other direction. And we're going to draw our blue graph in. And I'm going to label this one as y equals x squared so we can see the difference. Now for this first function only, I'm going to do a table of values. So if y is 0, or if x is 0, y is also going to be 0. If x is 1, y in this case, 1 squared times 2 is going to be 2. Same thing for negative 1. If x is 2, 2 squared times 2 is going to be 8. Same thing for negative 2. So our new function, if we graph it, is going to be 0, 0, 1, 2, and 2, 8. Same thing going in the negative direction, 1, 2, 2, 8. So you can see the values that we went up for the function y equals 2x are double what they normally would be. And as a result, our graph is a little bit skinnier. If we have y equals a half x squared, what that's going to do is it's going to cut our values in half. So again, if I graph a regular y equals x squared equation, just so we can compare, here are my regular pattern of squares, over 1 up 1, over 2 up 4, over 3 up 9. So that's what a regular y equals x squared looks like. Now when I add a factor of a half to it, what that's going to do, just like when we doubled our values for 2x, for 1/2 x, we're going to cut our values in half. So over 1, up a half. Over 2, instead of going up 4, I'm going to go up half that. So I'm going to go up 2. Instead of going up 3, or over 3 up 9, I'm going to go over 3 and up half of that, so up 4.5. Normally I'd go over 4 up 16, I'm going to go over 4 and up 8. Same thing on the other side. Over 3 up 4.5, over 4 up 8. So you can see when I draw a graph of y equals a half x squared, my graph gets a little bit wider. And the amount that I go up with my pattern of squares is multiplied by a factor of a half. If I have a negative in front of my answer, it's going to change my graph into the negative direction. So if I had a regular y equals 2x, from my vertex, I would go over 1, up 2. But because it's negative, I'm going to go over 1 and down 2. Normally I'd go over 2 up 8, but I'm going to go over 2 and down 8. So you can see it changes the parabola. Instead of a parabola that opens upward, it is now a parabola that opens downward. And this parabola would now have a maximum value as opposed to a minimum value. The same principle applies when we've added a translation. Remember, the value inside your x, inside the squared, is the translation on the x-axis, and the number outside is the translation on the y-axis. Now we need to remember this minus sign, so we're actually going to in the positive direction along the x-axis, and then 5 in the negative direction along the y-axis. But with the value of 3 out front, this value here is our compression or expansion. So when I graph this, I start at my vertex, which I've decided is positive 2, negative 5. My normal pattern of squares is over 1 up 1, but because of that expansion, I'm going to go over 1 up 1, 2, 3. Same thing on my negative side, over 1 up 3. My next value would normally be over 2 up 4, But because of that factor of 3, I'm going to go over 2 and up 12. So there's over 2 up 12. And we're going to do the same thing going in the negative direction. So you can see our parabola has been translated to a new vertex. And then our graph is made skinnier by the factor of 3. Similarly with 1/3, the first thing I'm going to do is look for my translation. So here's my x translation. I'm going to move positive 1 in the x direction. You can see my y translation. I'm going to move up 2, and there's my new vertex. Now because it's a factor of 1/3, we're going to have to do a little bit of estimating between the lines. So we would go over 1 up 1/3, because normally we'd go over 1 up 1. Normally we'd go over 2 up 4, but we're going to multiply that by 1/3, so we're going to go up 4/3. Normally we'd go over 3 up 9, 1/3 of that is going to be 3. And we do all of the same thing going in the other direction. So as a result, our graph gets wider than my regular y equals x squared. Finally, if we have a negative, we still look at our translation. So in this case, it's positive 1, which means I'm going to go to negative 1x. And it's positive 3, so I'm going to go up 3 and start my new vertex. Now normally I'd go over 1 up 1, but because I've got this factor of negative 2 in front, I need to multiply everything I would go up by negative 2. So instead of over 1 and up 1, it becomes over 1 and down 2. Same thing on the other side. Normally I'd go over 2 from the vertex and up 4, but I need to multiply that by negative 2, so I'm going to go 2 over, but now I'm going to go down 8. So that's going to bring me down to here. And I do the same on the negative side. Now for the next value, I would normally go over 3 up 9. Because of this, I'm going to go over 3 down 18, but that's going to be off our graph. So I draw in my lines here, and I get a nice downward facing parabola.